Let's review how we can do a hypothesis test when the population standard deviation is not known using the p-value method. We want to test a politician's claim that the average monthly rent payments are less than $1,000 a month. We collect a 30 household sample. Sample average is 1,060, sample standard deviation is 180, and the confidence level is 95%. So first we need to set up our hypothesis. The politician claimed that the average monthly rent was less than 1,000. So our null hypothesis is the average monthly rent is less than $1,000. Now what we're testing will be the alternative hypothesis. That the average monthly rent is more than or equal to $1,000. So to do this, and because we don't know the population standard deviation, we do know our sample standard deviation, we can use the following formula. Now our degrees of freedom in this scenario is n minus 1. Our sample is 30 households, so 30 minus 1. We have a degree of freedom of 29. So T, 29, is equal to our alternative hypothesis mean, or our sample mean, of 1,060, less our null hypothesis mean of 1,000, divided by our standard deviation for our sample, 180, divided by the square root of our sample size, which is 30. When we look this up, we get, and when we do the math, we get 1.827. So T to T29 with the degrees of freedom of 29 equals 1.827. Now this is a one-tailed test. So again, if it was two-tailed, if we were to say that the hypothesis does not equal 1,000 because it could be less than or more than. In this scenario, we only want to know if it's equal to or more than 1,000. So that would only be on the one side of the standard distribution. So this would be a one-tailed test. We then want to look up what the probability is using our t-table. So our degree of freedom is 29, which we can find here. And as we go across, what we're looking for is our 1.827. And we can see here that 1.827 falls somewhere in between these two numbers. So, if we go to the top, on our one-tail test, we can see that the probability is somewhere between 2.5% and 5%. So we have a confidence test a confidence level of 95%. By reverse looking up our probability, we know that the probability is 0.025 to 0.05%. Either way, wherever it falls in there. Now, for simplicity's sake, because this is roughly just past the 1.699, we can call this, say, 3%. Very roughly, it doesn't really matter because our p-value is less than our significance level. Our significance level is 5%, which is 1 minus 95. Or if we were to reverse this, 1 minus 3 would have a 97% chance. So we have strong evidence to reject the null hypothesis and accept the alternative. Basically, in other words, what this means is based on our sample, we would only get a sample average about 3% of the time or between 2.5% to 5%, we'd only get our sample average about that many times. So let's say 3%. And because we have a significance level of 5%, the fact that we got this average this time tells us that we probably have this null hypothesis is probably wrong and we can reject it.